Hi, I'm Sean Gannon, and this is minutemath, and today we're learning about more properties of exponents. So, if I had to simplify this problem.
Minute math. When you need help, you use minute math.
X to the negative 2 power times x to the negative third power, all to the fourth power here. So what do I want to do? Inside my parentheses, first, let's simplify that. We have the same base, we can combine that. When we multiply the same base, we add the exponents. So, negative 2 plus a negative 3 is a negative 5. So we have x to the negative 5 power here, all to the fourth power. Now let's continue. From here, we have the fourth power. Everything raised to the fourth power, that means we multiply these exponents. So, x to the power of negative 5 times 4, which is a negative 20. All right? Not done. We want positive exponents. X to the negative 20 is the exponent there. Is the same as 1 over x to the positive 20th power. And there we have our final answer. 1 over x to the positive 20th power. X to the fourth power, all to the negative third power, times 2x to the fourth power. Well, first thing here, the left, I have x to the fourth power to the power of negative 3. There we multiply the exponents. So we have x to the 4 times negative 3, which is a negative 12. Now, times 2, bring this part down, x to the fourth power. From there, where do we go? Well, we can put the 2, don't really worry about the coefficient of 2, okay? It's 2 times this coefficient, which really is 1, right? So we have 2 here. Then we have x to the negative 12 times x to the fourth power. In this case, we add the exponents. So negative 12 plus 4 is a negative 8. So we have x to the negative 8 power, and we're not done. We said we have to have positive exponents. So we know x to the negative 8 power is the same thing as 1 over x to the positive 8th power. So the 2 stays here, bring the x down, but now make it to a positive 8th power, and now we're done. 2 over x to the positive 8th power. N to the third power, all to the third power, times 2n to the negative 1 power. First thing I'm going to deal with here is n to the third power. Since we're raising this to another third power, we multiply the exponents. So we have n to the 3 times 3, which is 9 as our exponent. Bring down the 2, n to the negative 1 power. Again, let's look at the coefficient. 2 times the 1 in front of this coefficient. 2 times 1 is just 2. And now we have the n's. N to the 9th power times n to the negative 1 power. Here we have the same base. We add the exponents. 9 plus a negative 1 is an 8. So we have n to the 8th power, and now we're done. We have 2n to the 8th power as our final answer. 2v to the second power, that's all to the second power, times 2v squared. This one's tricky. Each one of these parts does something a little different. Let's deal with the first part here. 2v squared. The squared part is outside the parentheses. That means we have to apply it to both parts. So 2 squared is 4, and now v squared is just v squared. Bring down the 2v squared here, and let's continue. 4 times 2, let's deal with the coefficients, is 8. Now we have v squared times v squared. Since it's multiplication with the same base, we add the exponents here. 2 plus 2 is 4. So we have v to the fourth power, and now we are complete. We have 8v to the fourth power. 2x squared y to the fourth times 4x squared y to the fourth times 3. 3x. There we go. All over 3x to the negative third y squared. And double check and make sure I got everything, and I did. So a few things here. We could simplify the whole numerator, denominator, and try to work from there. What I try to do here is understand my properties better. This 3 in the denominator and this 3 up here can cancel. Right? They cancel each other out. We have a y squared here, but we have a y to the fourth up there. So y squared down here goes away. This fourth power becomes a second power, right? We subtract them. 4 minus 2 is 2. This one's a little tricky. We have x to the negative third power. Well, we'll look at the exponents here. 2, right, like base, 2 minus a negative third is like adding, right, let's put it over here. 2 minus a negative third is the same thing as plus a positive third, which is 5. So if I eliminate this down here, this exponent is to the positive fifth power. Now I have nothing left in the denominator. So let's rewrite this. Okay, let's put all of our, let's say, numbers first here. We have 2 and a 4, right, got those down, times x squared, so the x's, then we have x to the fifth power. We have both x's here. Oh, and that one x over here. Can't forget that. Then we have y to the fourth power here. Let's bring the other y, which is now y squared. Let's make sure we got it all. 2 here, put a dot underneath it, dot under here, got the 4. Got this x squared right here, and this x to the fifth power as well. And that x right there. We have y to the fourth power here, and this y squared there. So now we've brought everything down on one clean line. Let's simplify it. 2 times 4, 8. X squared times x to the fifth, add the exponents, x to the seventh power. Oh, don't forget the other x. Almost did. Classic mistake. Good thing I caught it before I finished the video. I would have had to restart. We have x to the seventh plus another 1 here, which is x to the eighth power. Okay? And then our y's, same base. 4 plus 2 is 6. So now our final answer is 8x to the eighth power, y to the sixth power. 2y to the third power times 3x y to the third power over 3x squared y to the fourth power. Okay? First step here. Well, what I try to do if I can is eliminate some things before I simplify on the numerator and the denominator. We see a 3 here and this 3 here. They can cancel each other out. Now we have, let's go with the, I guess, x's first. We have an x up here in the numerator and 2 x's down here. So we can get rid of 1 here and get rid of that 1x up there, and we have the x to the first power down here. Now our y's. We have 3 y's here and 4 y's there. So 3 y's eliminate that 4, leaving us 1 left over. And then y to the third power over 1 y here, y to the first power, gets rid of that full y, make that a 2. Okay, that was a lot of steps. So let's clean up what we see in the numerator and denominator, where we go from there. 2, right there is left over. We got rid of all that, and we're left with just a y squared. Anything else in the denominator, and we have just this x. Don't forget it. And that's it. There's nothing else to simplify. So our final answer here is just 2y squared over x. X to the third times y to the third times x to the third, all over 4x squared. Well, let's look at our x's here. We have x squared and x to the third right there. We can simplify that. 2 x's down here get eliminate 2 in the numerator. There's 3 up there, so if you get rid of this, we're left with just 1 x there. So now let's go combine our like terms in the numerator. X to the third times x. Add the exponents. There's a 1 there. 3 plus 1 is 4. So we have x to the fourth power. Y has nothing else that can be combined with it. Y to the third power, all over our denominator, which is just 4. And that's actually it. We're done. X to the fourth times y to the third over 4 is our final answer. 3x squared, y squared, all over 2x to the negative 1 times 4yx squared. First thing I want to do here, let's see what we can eliminate from the numerator and denominator. Well, I see an x squared here in the denominator, x squared here in the numerator. I can cancel them out. Makes it easier. Now let's look at our y's. We have 1y down here and 2 up in the numerator. Cancel that out. Cancel that out. We're left with 1 there. Don't forget it. Now, notice here, this x to the negative 1, that thing can be sent to the numerator if we make it to a positive 1. So let's do that here. The 3 is right there, and then we bring the x to the numerator, so we have x to the positive 1 power, and then don't forget this y right there. Okay? Denominator we have left is just 2 times 4, which is 8, and we're pretty much done. There's nothing else that we can simplify. It kind of worked out pretty nice. Our final answer is 3xy over 8. X over 2x to the 0 power all squared. What would I want to do here first? Okay, this one's a little tricky. This x to the 0 power, I'm going to recognize that and know that anything to the 0 power is just 1. So with that being said, I can basically kind of just cross that out. It looks like a big X now, so I'll do this. But it's just a 1 now. So now we have x over 2 times 1, but we don't need to write that, but I guess we'll do it like that. Don't need it. To the second power. So we have x over 2 to the second power. Well, it's 2 squared. That's 4. So we have x over 4, and now we're actually done. This is a fairly easy problem. Our final answer is just x over 4. 2m to the negative 4th power over 2m to the negative 4th power, all to the 3rd power. So this one's actually kind of tricky, and we're going to do some smart finagling here. See this. Think of 2m to the 4th power as its one whole unit. It's the same thing written down here in the denominator, except there's 3 of them. Okay, so watch this. This is the same thing as 2m to the negative 4th power over 2m to the negative 4th power to the 1st power, right? One of them, that's what we have up here, times 2m to the negative 4th power squared. Okay? Now watch this. This one can cancel with that one, leaving us with just 1 over 2m to the negative 4th power squared in the denominator. So now we can simplify this. Bring the squared in to both parts in the denominator, and we have 1 over 2 squared, which is 4. And we have m to the negative 4 power times 2, remember multiplication here, negative 8. Well, we can't have negative exponents, they need to be positive. We can bring that to the numerator, right? So we have m to the positive 8th power over 4 as our final answer. 2m squared all to the negative 1 power over m squared. Well, what should we do here? Well, this is what I'm going to do. I see all of this to the negative 1 power. So I'm going to bring all of that to the denominator and put it to the positive 1 power, which we do not need to write, right? So 2 different writes there. So we bring down, or just keep the m squared down there. It has to be a 1 in the numerator. But we bring down the 2m squared to the 1st power, but we don't need to write that, right? The 1st power is there, but it really doesn't mean anything. So now we can simplify just the denominator. 2 times this coefficient in front of the m squared, there's just 2. There's nothing. There's a 1 there. 2 times 1, 2. But now our m's. We have m squared times m squared. Here, the same base, we add the exponents. 2 plus 2 is 4. You should know that. So we have m to the 4th power, and there we're done. Our final answer here is just 1 over 2m to the 4th power. 2x to the 3rd power over x to the negative 1, all to the 3rd power. Well, what do I want to do here? This denominator, I want to simplify first. So we'll keep the numerator, 2x to the 3rd power, but the denominator, we have x to the exponent, negative 1 times 3. We multiply these exponents when it's raised like that. Negative 1 times 3 is a negative 3. Okay. Now, be careful. I know you just want to cross them out and be done. Incorrect. Negative exponent needs to go into the numerator, makes it easier here. And we can do that by making a positive exponent. So we have 2x to the 3rd times, bring this x to the negative 3rd to the numerator, and it's a positive to the 3rd power. So x to the positive 3rd power. Now we have the same bases. We need to add the exponents. 2 comes down. X, we add the exponents. 3 plus 3 is 6. And we're done. We have 2x to the 6th power as our final answer. A to the negative 3rd times b to the negative 3rd, all to the 0 power. This one's tricky, but easy too once you know the rules. Everything here inside the parentheses is raised to the 0 power. What do we know about anything raised to the 0 power? And that is it's 1, right? 5 to the 0 power is 1, 10 to the 0 power is 1. X squared all to the 0 power is 1. So all of this raised to the 0 power is just 1. And then we're done. Our final answer, 1. X to the 4th times y to the 3rd times 2y squared all to the 0 power. This one's actually very easy, but you don't want to get ahead of yourself and start just multiplying. Take a moment and look at it. We have this second part here all raised to the 0 power. Anything raised to the 0 power is 1, right? So what's inside is just going to be 1. So we have x to the 4th times y to the 3rd times 1. And how often? Well, really never. We would write times 1. So our answer is just x to the 4th, y to the 3rd. There's nothing else that we can simplify, and that is our final answer. ba to the 4th power times 2ba to the 4th, all to the 3rd power. Notice we have this thing here, ba to the 4th, and I see a ba to the 4th. This will be important later. What I'm going to first do is actually take this negative 3rd power and, well, there's a few ways. I can bring it to the denominator, but actually no, I changed my mind. I'm going to distribute it here, okay, to each part as such. So we have ba to the 4th power here times 2 to the negative 3rd power times b to the negative 3rd power times a to the 4 times negative 3. Remember, we multiply that out, and we have a negative 12. Okay? So now we want to combine our like terms. Well, 2 to the negative 3rd power is by itself, and well, we really can put that in, well, let's put it up front here. 2 to the negative 3rd power. Let's write that first. And then let's go with the b's. We have b to the 1st power, right? And b to the negative 3rd power. Multiply them together, we add the exponents, we have b to the negative 2 power. 1 minus 3, negative 2. So we've got this 2 to the negative 3rd we brought over. We've dealt with the b's, now we just have the two a's. We have a to the 4th power times a to the negative 12. Again, we add the exponents. So 4 plus a negative 12 is a negative 8. And we're almost done. Why are we not done yet? Well, we have to bring everything down to the denominator, right? Can't have any positive exponents. Luckily, this is now very easy to do so. All these values can come down with a positive exponent. Negative in the numerator here makes it a positive in the denominator. So 2 to the 3rd, b squared, and a to the 8th power, all underneath 1. Well, 2 to the 3rd, we know what that is. 2 times 2 is 4, times 2 is 8. So we have 1 over 8 b squared, a to the 8th power, and now we're done. That is our final answer. 2x to the 0 power, y squared, all to the negative 3rd power, times 2yx to the 3rd power. What do we need to do from here? Well, x to the 0 power is just 1, so we don't really need that, okay? And we kind of cross it off. This is multiplied by 1. That kind of makes things a little easier here. This negative 3rd power means that we can put this whole thing in the denominator but raised to a positive 3rd power. So I'm going to take this part here, leave it in the numerator, 2y x to the 3rd, but this part here is going to go down to the denominator. So we have 2y squared. Remember, the x to the 0 is just 1. Don't need to write that. And negative 3rd power becomes a positive 3rd power. Okay. Well, now let's distribute it. 3 can go to both parts here. Well, numerator stays the same, 2y x to the 3rd. Denominator, 2 to the 3rd power is 8. Y squared to the 3rd power, we multiply the exponents. That's a y to the 6th power. Okay? And now we need to simplify a little more. 2 and 8, that becomes a 4, right? 2 divided by 8 is a 4, or 1/4. Y to the 6th cancels out with this 1y. That y is gone, and we y to the 5th. So lastly, we're just done. We have x to the 3rd coming down. Let's simplify. 4 here, y to the 5th power, and now we are done. That is our final answer. 2k to the 3rd power, k to the 2nd power, all over k to the negative 3rd power. One thing we know about negative exponents is that if it's negative in the denominator, it's a positive in the numerator. So we're going to take this and bring it to the numerator. So we have 2k to the 3rd, k squared, and then we're going to multiply that by bringing up k to the positive 3rd power. Well, one thing we know with our rules of exponents here that we're practicing, we have the same bases that we're multiplying, we add the exponents. So 2 comes down, we have a k, let's add it up. 3 plus 2 is 5, plus 3 is 8. So our final answer here is just 2k to the 8th power. X to the negative 3rd power, all to the 4th power, times x to the 4th power, all over 2x to the negative 3rd power. What do we need to do here? Well, first thing I'm going to do is actually distribute this 4th power exponent inside here. So we have x to the negative 3 times 4. Remember, we multiply the exponents. So we have a negative 3 times 4, which is a negative 12, times x to the 4th power over, we have 2x to the negative 3rd power here. Okay? Well, let's keep dealing with the numerator. We we add our exponents, we have the same base. X to the negative 12 times x to the 4th. We add the exponents. Negative 12 plus 4 is a negative 8. So we have x to the negative 8 exponent over 2x to the negative 3rd. Okay. Now this is tricky. Let's look at this, right? We have a little note here, division. Same base, x is here. Look at the numerators, negative 8, minus 3. So if you take negative 8 minus a negative 3, because we subtract over division, that's like plus a positive, which that comes out to be 5. Okay? So with a 5 there, though, or negative 5, excuse me, negative 5. And so what that does is bring that in, it's a negative in the numerator, positive then in the denominator. So we have 1 up in the numerator, and we have 2x to the positive 5th power in the denominator, okay? And the way you can kind of see it is we have a negative up here, negative down here, but combined kept it negative. Negative 8 was the bigger number, keeps it down. So it's a negative 5 in the numerator, positive 5 in the denominator. And so our final answer is 1 over 2x to the positive 5th power. 2x all to the negative 4th power over x to the negative 1 times x. Let's deal with the numerator and denominator separately at first. Numerator, distribute that negative 4 to both parts here. 2 to the negative 4th power times x to the negative 4th power. Now the denominator. And this one's actually kind of tricky. We have x to the 1st power here, but they didn't give it us from the beginning, the 1, but we know it's there. Our rules say same base, we add the exponents. Negative 1 plus a positive 1 is 0. So we have x to the 0 power. Now that's not dividing by 0, it's divided by x to the 0 power, which we know is 1. Okay, so now we have negative exponents. We know negative exponents in the numerator are positive in the denominator. So we're going to bring those down. Doing so, we have 1 over 2 to the positive 4th power times x to the positive 4th power times x to the 0 power. That x to the 0 power we know is just 1, so we don't really need to write that. And now let's keep simplifying. We have 1 over 2 to the 4th power. Well, 2 to the 4th power is 16. So we have 16 here. We have x to the 4th power, is just what's left over. And then we're done. That is our final answer, 1 over 16x to the 4th power. 2x to the 3rd power, z squared, all to the 3rd power. Divided by x to the 3rd, y to the 4th is z squared times x to the negative 1, z to the 3rd power. What am I going to do here? First step here is I'm going to simplify the numerator and simplify the denominator. This 3rd power can be applied to all individual parts in here. We have 2 to the 3rd power right there. And then x to the 3rd power to the 3rd power, we multiply the exponents. 3 times 3 is 9. Z squared to the 3rd power, 2 times 3 is 6. Here's z to the 6th power. Divided by the denominator, we can simplify here. Okay, so let's be careful. Our x is x to the 3rd, and we have x to the negative 4th. When here, they're all being multiplied across, we add the exponents. So 3 plus a negative 4 is x to the negative 1 power. Now the y's, no other y in the denominator, right? And so that just comes over, y to the 4th power. Now time for the z's. Again, add the bases. Z squared, or add the exponents, same base here. Z squared times z to the 3rd, 2 plus 3 is 5. So we have z to the 5th power. So now, let's see where we can go. We go with our rules here. Okay, simplify. 2 to the 3rd power, 2 times 2 is 4, times 2 is 8. Okay, now this one's tricky. We have x to the 9th and x to the negative 1. Division, we subtract the exponents. So 9 minus a negative 1 plus a positive, right, same thing, 10. So numerator, we have x to the 10th power here, okay? So we've dealt with the x's, we dealt with the number. Let's deal with, well, let's deal with, I guess, the z's next, the next thing in the numerator here. Z to the 6th divided by z to the 5th. Subtract the exponents. 6 minus 5 is 1. Z to the 1, we just write z. z is gone. Now we're left with just that y to the 4th power in the denominator. And now I'm done. Our final answer is 8x to the 10th power z over y to the 4th power. 2pm to the negative 1 power q to the 0 power all to the negative 4 power times 2m to the negative 1 p to the 3rd power divided by 2pq squared. Okay. What I'm going to do here first is I'm actually going to kind of do a mix of things. I'm going to try to simplify what I can in the numerator and denominator, but if there's anything I can cancel out right now, I'm going to try. We have a 2 here. I can cancel out with this 2. Don't need to write that. Let's look at the p's. We have 1p here and 3 p's up there, so now we're left with just 2 p's up here. The q's, I'm not going to do anything here because in reality, right, this q to the 0 power is just 1. Don't need that. Okay, done some canceling out. Take our time here though. Let's go see what we have left over. Let's distribute the negative 4th power to our parts that are left in that parenthesis. We have 2 to the negative 4th power here, p to the negative 4th power. M to the negative 1 times a negative 4 is a positive 4. Remember, we multiplied the exponents here. So we have a positive 4th power here. So we have m to the positive 4th power. Okay, got all that done. Times, what's left? M to the negative 1 times p squared. Okay, denominator here is just q squared. All right, so where can we go from here? Well, what I'm actually going to try to do again is keep simplifying, which is a little easier to see now, the numerator. So let's bring that over here. Just going to like that. And what I'm going to do is, well, kind of actually. First thing, I'm going to bring this negative exponent, the 2 to the negative 4, bring it down to the denominator because there is nothing else here to really divide. So I'm going to bring it down there. So we have 2 to the positive 4th power. All right, now our p's. We have p to the negative 4th times p squared. We add the exponents, right? We have the same p's, same base. We add the exponents. Negative 4 plus 2 is a negative 2. So we have p to the negative 2 in the numerator here. Our m's, m to the 4th times m to the negative 1. Again, add the exponents. 4 plus negative 1, 3. So we have m to the 3rd power here, and that's everything in the numerator. Let's just have the denominator q squared. Okay? Last step here. Well, a couple things we're doing the last step. Let's bring that, we're going to bring that p squared down, p to the negative 2, to be a positive 2 power, the denominator. But first we have 2 to the 4th power. 2 to the 4th power is 16. So we have 16 here. We're then going to bring down the, so we bring down the p squared right there. And lastly, the q squared stays down there. Sorry, I was just making sure I did it right. I did. And the m to the 3rd stays in the numerator, and now we're done. Our final answer here is just m to the 3rd over 16p squared q squared. 2h j squared k to the negative 2 times h to the 4th j to the negative 1 k to the 4th all to the 0 power divided by 2h to the negative 3rd j to the negative 4th k to the negative 2nd power. What a doozy. Well, one thing here I'm noticing from the beginning, before you start diving in, let's do something simple. All of this whole numerator basically is raised to the 0 power. What is anything raised to the 0 power but 1? So this whole thing just becomes a 1 in the numerator. Okay? So let's rewrite the denominator. And hopefully you should be breathing a sigh of relief here because the majority of the problem is done. Now it's not too bad. Well, we can't have a negative exponent, so we make them positive. So all these negative exponents in the denominator become positives in the numerator. So let's do that right here. We have h to the positive 3rd, j to the 4th positive 4th power, and k to the positive 2nd power, or squared, all over. Don't forget that 2 that stayed down in the denominator. And now we're done. Had you fooled for a moment, you thought that this was going to be a hard problem. You were scared, but now we're done. So our final answer, h to the 3rd, j to the 4th, k to the 2nd power, all over 2, and we're done. If this video helped you, please subscribe to our channel and like this video. This helps us make more free math lessons for you. And as always, thanks for watching.
Minute Math. When you need help, you use Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.